Good day and welcome back for the fifth and final installment on differentiation formulas. As I mentioned at the end of the previous video, we'd finished covering all of the material and we've worked through examples, and it was time for you all to practice. So hopefully you took the time to locate and work through the problems on the worksheet. And I'd like to just go over two of these problems from number 1, where we are asked to differentiate some long list of functions. For part B of number 1, we're simply asked to differentiate the function 4x squared plus 3 quantity squared. And I realize we've gone over something similar in one of our previous videos, but I really want to emphasize and reiterate this point. We cannot apply the power rule. And trying to apply the power rule, at least at this point, in this incorrect scenario is a very common mistake. So I just want to emphasize that. But what we can do is rewrite this. So we can write it as 4x squared plus 3 times 4x squared plus 3. And once we have this expanded out, we now have two choices. We could continue expanding further and get a polynomial and then simply apply the power rule a couple times, or you could use the product rule, whatever your preference might be. So let's go ahead for fun and just expand this out one step further. So we would have 16x to the fourth plus 24x squared plus 9. And if we now differentiate term by term, we would have 16 times 4x cubed plus 24 times 2x. And remember, the derivative of a constant is always 0. And you certainly could take this a step further, but I'm going to leave it exactly in this form. Whether we simplify it further by combining some numbers together, i.e. doing some arithmetic, or not, this is a version of the correct solution. So moving on to a second example I wanted to say something about was part E. Now, what I want to remind you of is that it's worth taking a moment or two to think about your approach before just blindly starting to write stuff down. So one thought would be just, oh, a function times a function, I'm going to use the product rule. And that certainly would work, but in terms of maybe a more efficient approach, we could first algebraically pass that x to the fourth through, and then instead of having to do both a product rule and a quotient rule in the same problem, which is perfectly fine, we will just have to do a power rule in the quotient rule. That is, we'll be left with the derivative of the quantity x to the fourth minus 2x to the fourth over x plus 1. So just working from left to right, term by term. By the power rule, the derivative of x to the fourth is 4x cubed. And when we differentiate this quotient, we use the quotient rule. And remember, whenever you use the quotient rule and the power rule up through our first exam, I need you to indicate to me specifically how you are using it, i.e. write out what that formula tells you. So the quotient rule tells us the following: low d high minus high d low, all divided by low squared. And the nice thing about writing this out is hopefully we won't make some small silly mistakes, but it very clearly shows you kind of the hopefully simpler two derivatives that we now need to evaluate. So working from left to right again, the derivative of 2x to the fourth will be 2 times 4, or 8, x cubed, minus 2x to the fourth times the derivative of x plus 1. And differentiating term by term, that would be 1 plus 0. And note, you don't have to write the plus 0, and in this case you don't even have to write the 1 because 1 times anything is that anything, but I want to make sure you see precisely how we differentiated each of those terms. And then we are dividing by x plus 1 quantity squared. And as I've mentioned at this point multiple times, you don't have to simplify any further. When you are simply asked to differentiate a function, once you get down to that derivative, you're good to go. When we need to simplify later on, we most certainly will do so. So that finishes up our discussion on differentiation formulas. Once again, make sure you're going to suggested problems, you're practicing with a focus on understanding. When you have questions, do not hesitate to stop by or drop me an email. So stay tuned and take care.